Now, continuing with our theme, in this video, inshallah, we'll talk about the stopping distance. Assume that there is a driver who sees a red light. This right here is where the driver observes the red light, and here it is the red light. Your driver is essentially going to apply brakes and eventually come to a stop right where the red light is. This whole distance right here, where the driver sees the red light first, and then where the driver stops, is essentially known as the stopping distance. Now, the stopping distance is not that the driver is going to observe the red light and immediately apply brakes and come to a stop. Stopping distance is essentially made up of two components. Number one, thinking, and number two, braking. Now, why do we say that there's thinking involved? Well, thinking is involved because as your driver observes, the driver over here observes the red light, the eyes are going to send a signal to the brain, which tells the legs to apply brakes. All right. So the process in which, or the time in which this is happening, the eyes sending a signal to the brain and the brain sending a signals to the legs, is known as the thinking distance. And this is something that we normally call reaction time. All right. So the normal reaction time for a human being is approximately 200 to 300 milliseconds, or 0.2 to 0.3 seconds approximately. And the distance traveled in those 0.2 or 0.3 seconds is known as the thinking distance. Now the legs know that they're supposed to apply brakes. So at this point right here, your legs will start applying the brakes. Of course, the car does not come to a halt immediately after applying brakes. It travels a certain distance. So this distance right here, while the brakes have been applied, is known as the braking distance. Let's recap. Thinking is the time the driver takes to decide to brake. The distance traveled during this time is known as the thinking distance. As we know that distance or displacement is the area under graph, where velocity time graph is given, so you can easily figure out the area under the graph to figure out the thinking distance. The time a car takes to brakes is known as braking time. The distance traveled while braking is known as the braking distance. Again, you have a velocity time graph, and the distance or the displacement during this time can again be easily figured out using area under the graph. So I hope that this makes it clear. There are several factors that can affect thinking or braking distances. Like, let's say, for example, thinking distance can be affected by the amount of sleep that you have. If you're sleep deprived, your reaction time increases, your thinking time will increase, and the car will travel a much larger distance during that period of time. On the other hand, the braking distance can be affected by the surface of the road. If the surface of the road has more or less friction due to being wet or dry, that can affect the braking distance. Number two, the weight of the vehicle changes the braking distance. Means, let's say if you have more people in a car, the braking distance will increase. Number three, the condition of tires that you have. If your tires are worn out, the braking distance will increase, while newer tires brake better than older tires. So your braking distance on newer tires will be smaller. That's it for this video, kids. Inshallah, I'll see you in the next one. Bars out.